Good morning. Happy April Fool's Day. Today we are going to be talking more about line plots. We are going to make line plots and interpret data from these line plots. So let's take a look at our first problem. Jacob works at a shipping center. He recorded the weights of packages one day. The weights are listed below. So we have some raw data here, which just means it is in a data table that is not organized in any way. It is just listed. So what we're going to do is we are going to take the data and we're going to put it onto a line plot. So I've already started the line plot. I have already drawn my line with a ruler, put arrows on each end, and then I have written below what the line plot is about. So this line plot is about package weights, and the unit that we are using in this case is pounds. I got this information from the description of the situation because it's talking about packages being weighed, and I see from my data that it is in pounds. So this LBS, that is the abbreviation for pounds. Okay, so what we're going to do is we're going to take a look at our data and we're going to find our smallest weight. So if I'm looking in, I see some weights that are in 1.5, and I'm going to look and see if anything is below 1.5. The answer is no. There is nothing that was recorded below 1.5. So I know that is going to be my low, and then I see I have a few of those. Now I want to look for my high weight. My high weight is the 4. So the highest weight in this situation is my 4. And I think I only have one of those. Yes. Now when you go to make your line plot, you're going to think about how am I going to divide up my line. So I'm thinking what I might do, since I don't have very much difference between my highest and my lowest, is I might go up by halves, and my lowest is 1.5, so I think I'll start with a 1. So I'm gonna see if I use like this inch ruler, maybe I could make a line here and make that 1, and then I could do, let's see, maybe here I could do 1.5. Here I could do 2, 2.5, 3, 3.5, 4, and then I might go up to 4.5. I think that's going to work. So you kind of have to think about how am I going to do this to make all my data fit. And you have to also remember that even if you don't have a weight, you can't just skip up to the next measurement. So let's go ahead. I'm just going to mark these. Make sure you can, okay. So here's going to be my first one. Then I'm going to go to my half, 1.5 inches on my ruler. I'm just trying to keep my divisions here separate or equal in length, just about. They don't have to be perfect. Just, pretty close. I'm trying to do my best here. Whoops, it's hard to do one-handed. Okay, that should do it. Now, I'm going to get rid of this ruler for a sec. And we decided we were going to do the 1. Even though we don't have any of those, you really should go ahead and do at least one below and one above. Go one below your lowest and one above your highest. And we have to go up by halves. So my next one up, even if I don't have any, would be 1.5. Now I think I do have some 1.5s. The next one up has to go up by another half pound, so that's going to be a 2. The next one up has to go up by another half a pound, so 2.5. The next one up, another half a pound would be a 3. Another half pound would be a 3.5. Another half pound would be a 4. And then that is my highest, and I'm going to go 1 up. Now, I accidentally, I guess, made an extra, so I'm just going to go ahead and do a 5. Why not? Okay, so Notice we have not skipped any halves. So now we're going to actually place our X's. So on our line plot, I'm going to switch over to a color here. Let's start making X's. So I'm going to start with my 2.5. And as I use them, I'm just going to cross them off. You could also do this more systematically, and actually I might do this starting with your littlest. So let's go to our littlest. We have 1.5 pounds. So I'm going to go down to my 1.5 and make my first X. Okay, and I'm going to cross off my first 1.5. Now I see I have another 1.5, so I'm going to cross that off. Oops, I need a little bit more. Make another X. Okay, and I think that's all of them. Okay, now let's see our next one up. So we have some 2's in here. So let's see, how many of them do we have? We have 1, 2, 3. 3 of the 2's. So I'm just going to go ahead and do 1, 2, 3, and cross them off. 1, 2, 3. Now, let's see, 2.5. How many of those are there? Let's see, 1, 2, 3. That's it. So 3 of the 2.5's. 2, 3. 1, 2, 3. That's all of them. How about 3's? Do I have any 3's? Let's see, 1, 2, 3, 4, 5. Oh my, 5 of those. So this one has the most so far, doesn't it? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Just making sure I have the correct number. Okay, and then I have some 3.5's. 1, 2. So I have just 2 of those. So 1, 2, cross off, cross off. And then I'm left with just 1 4. So just 1 X there. Okay, I used all of my information, and now here is my line plot. We're going to use this line plot to answer a couple questions. So we'll keep that handy, and let's take a peek at our questions. Number 1, it says, what is the weight of the lightest package? So if we use our line plot, the lightest package is not 1 pound because we don't have any of those. Do you notice that? The lightest package is 1 1/2 pounds. So the lightest package is 1 1/2 pounds. What's the heaviest package? Let's see here. The heaviest package is not 5, of course, because there aren't any of those. The heaviest package is 4 pounds. C, let's see. How many of the lightest packages are there? So the lightest package was 1 1/2, and how many packages were at that weight? The answer is 2. What is the number of the heaviest? So how many of the heavy packages were there? There was only 1 of those. And then let's see. And E, how many packages were weighed in all? So this is where people mess up. Oh, 5 pounds. No, that does not make any sense whatsoever. How many packages were weighed? Go back up to your data table. How many packages did we actually weigh? Okay, you can also just go to your line plot and simply count the X's. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 packages. Okay, now we're going to throw in a mode and a range just for fun. The mode, of course, we remember what this means because it's the one that happens the most often. So what was the weight of the package that occurred most often? That is the one that has the most X's. So which package weight had the most X's? And that is 3 pounds. So the mode in this case is 3 pounds. Okay, now the range. To find the range, you take your highest weight and you subtract your lowest weight from it. So that is going to be our range. So our highest weight was a 4, our lowest weight was a 1 1/2. So let's do a little problem here. We're going to do 4, subtract 1 1/2. Now, you may be able to do this in your head, but you need to be careful, okay? Notice we have to do a little work here because we have 4 and there's no fraction here. And we have to take away 1 1/2. So you cannot take a half away from nothing. So what we're going to do is we're going to borrow from our neighbor. Okay, our 4 here has a lot because this is actually 0 halves, guys. It's just not written there. That is 0 halves. You can't take 1 away from nothing. So what we're going to do is we're going to go over to our big 4. Okay, he has lots of halves, lots and lots of them. So we're going to say, okay, can we please borrow 1 whole from you? Sure. So if we borrow 1 whole from the 4, he turns into a whole number 3. Now, we still have this whole number 1 that we borrowed from our 4. Okay, so we have this whole number 1. Okay, and we have to think to ourselves, how many halves are in 1 whole? How many halves are in 1 whole? 2 out of 2. 2 out of 2. So what you're going to do is you're going to put that with whatever's here. Now what was there was nothing. So it just turns into 0 halves plus 2 halves, which turns into 2 halves, just 2 halves. So now we have 2 over 2, take away 1 over 2. And now we can actually subtract. So we say 2 minus 1